All right, section 7.6 is on right triangle trigonometry. This is again a review from geometry class. These are your 6 trig ratios, okay? SIN is abbreviation for sine. The sine of an angle is a given ratio. That ratio is the same for every angle. It doesn't matter if you had a 30-degree angle in an itty-bitty triangle or a 30-degree angle in a humongous triangle. The ratio of these sides is going to be the same. So the ratio for sine is the length of the opposite side over the length of the hypotenuse. The ratio for cosine is the length of the adjacent side over the length of the hypotenuse. And then the ratio for tangent is the length of the opposite side over the length of the adjacent side. These 3 are reciprocals or flipped versions of these 3. So CSC stands for cosecant. It's an abbreviation for cosecant. You flip the sign, so it becomes the length of the hypotenuse over the length of the opposite side. SEC is secant, is the flip of cosine. You take the length of the hypotenuse over the length of the adjacent side. And then this is cotangent, which is the reciprocal of tangent. So it becomes the length of the adjacent side over the length of the opposite side. And I'll show you when we go through problems, if you're not quite sure about adjacent and opposite and things like that, well, I'm going to draw pictures for all these, okay? But these are the trig ratios that you need to know. And honestly, if you know those 3, then you know those 3. So a trick for remembering sine, cosine, and tangent is the mnemonic device SOHCAHTOA. Sine stands for opposite over hypotenuse. Cosine stands for adjacent over hypotenuse. And tangent stands for opposite over adjacent. Okay? So if we look at exercise 1, they give us a triangle. And all of these triangles that you have for this assignment are all going to be right triangles. Okay? You can do trigonometry without right triangles, but right now we're just dealing with right triangle trig. So for this triangle, find the values of sine, cosine, and tangent. So the first thing that we need is we need this other side. So we have to do the Pythagorean theorem to find this side. So 3 squared plus x squared equals 7 squared. 3 squared is 9 and 7 squared is 49. And so x squared is 40. So x is the square root of 40, okay? And they are going to ask you to reduce these. So 40 is 4, which is a perfect square, times 10. So this is equivalent to 2 square roots of 10. So remember, with square roots, they can't have a perfect square factor, so this is reduced. So we want the sine, cosine, and tangent of that angle. That symbol is a theta, and it's just a symbol, a Greek letter that's used for a variable. It's just like a letter of the alphabet, but it's a Greek letter. So sine is opposite over hypotenuse. The only one that we know for sure is the hypotenuse. The hypotenuse is the one that's opposite the 90-degree angle. The side opposite an angle, I can always draw an arrow to that, okay? Notice that this angle isn't made up of that side. It doesn't touch that side. So this is my side opposite, which leaves this side right here to be my side adjacent, okay? So sine is opposite over hypotenuse. So I have 2 square roots of 10 over 7. Cosine is adjacent over hypotenuse. So the ratio for cosine is 3 over 7. And tangent is opposite over adjacent. So I have 2 square roots of 10 over 3. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. You're finding the ratio of some angle. And right now we don't care what that angle is. Later on we'll use the calculator to actually find that angle. So check your progress 1. For the right triangle, find the values of sine, cosine, and tangent of theta. Okay, so again, the first thing we need to do is find that hypotenuse. This again is the side that's opposite the 90-degree angle. So this is my hypotenuse. So I need to do the Pythagorean theorem. So 3 squared plus 4 squared equals x squared. If you remember from geometry about Pythagorean triples, you will probably remember that 3, 4, 5 is a Pythagorean triple. It's a right triangle. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Take the square root of both sides, my hypotenuse is 5. So my side opposite in this particular one is my 3. So that leaves this to be my side adjacent. And if you have to draw a triangle and label opposite, adjacent, hypotenuse, you go for it, okay? Whatever you need to do to get these right. So the sine of my angle is opposite over hypotenuse, so that becomes 3 over 5. The cosine of my angle is adjacent over hypotenuse, so 4 over 5. And tangent of theta is opposite over adjacent, so that's 3 over 4.